In this section, we are going to discuss other hints related to migrating your campus network from flat to rooted as part of the campus network design and operations workshop. So these are some other hints that you might want to work with. And the first is to plan within your constraints. For example, some of your switches might be dumb, so they are not configurable. Some parts of your network must be in service at particular times, and you need to make a plan that best fits your situation. If your switches are dumb, and then you need to figure out, are you going to move them closer to the edge? Are you going to make sure that they're only in one VLAN? Are you going to replace them? If you must book downtime, you have to make sure that, for example, an exam is not running, an online exam is not running at the time you're shutting things down. So your plan has to fit your situation of your network. There are other hints and tips. So, for example, if your switch, like we provide your core switch and it might have only SFP ports, and this is, for example, like a fiber switch would be, for example, like a Nexus switch can come with all fiber ports. So having a copper gigabit SFP is very useful for testing because you can plug it into the port and connect your laptop directly into it. Secondly, if you move an IP address from one device to another, some devices might have the old MAC addresses cached in their app table. Cisco routers can keep them for up to 4 hours. So you might need to clear the app cache on the switches if you move an IP address from one device to another. Also, as soon as a change has been completed and tested, remember to write mem to save the configuration onto the device, so that in case there are any issues, a power outage or somebody hits the power cable, the saved configuration is the last tested good to know configuration, the last step that you tested, so that you don't have to start figuring out where each device is. If you're renumbering servers, remember we recommend that all your servers have DNS entries, but you need to reduce the DNS time to live in advance of the changes, and you need to allow for enough time for all the caches to expire the records with the old time to live, and then you can put it up afterwards. This is similar to the discussion about DHCP lease times in a different section. If you are renumbering servers that are on the same VLAN, sometimes you could add a secondary IP for the new IP, so that both old and new IP addresses are active at the same time whilst you migrate things. And then eventually, when you're sure that nobody's using the old IP, you remove it and have just one IP address. This allows you to have both at the same time, especially on your server's network. You can do this on the router side. You add a secondary IP address for the old VLAN as a gateway. And you can also do this on the server side where you have multiple IP addresses. You add the old one as a secondary and the new one is on until you've done migrating everything. The last thing you need to think about is static routes. When you've migrated your campus network and you have individual, or they could be dynamic, it depends on how your campus is set up, and you have individual subnets, like we have inside this diagram, you will need some routes for the border router to reach the addresses inside your core router. And you could either have individual routes for each network, the different /24s, and the next hop would be the IP address of the core router that the border router knows, that 10.1.255.2. Alternatively, you could say the entire /16 is available via the core router. Then on the core router, you now need a way to reach the internet in general. So you need a default route that points to the border router. So the next hop of the default route would be 10.1.255.1. And it's also important to add a null 0 route for the /16. And this is important because if you look at this subnet, you are only using 6 subnets out of the /16, including the 1.255 that you're using for the point-to-point. But you've only used 10.1.1, 10.1.2, 10.1.3, 10.1.4, and 10.1.0. There are other unused subnets in the 10.1 range that exist out of the /16. For example, 10.1.20 is not used. If a packet arrives at the border router with a destination of 10.1.20, it will send it down to the core router. Now the core router is directly connected to each of these devices, and it does not know what to do with a 10.1.20 yet until somebody creates a building 20. So it's going to use the default route to send that packet back to the border router. And the border router is going to look at the destination, and the destination is the /16, which is down. So you create a routing loop of a packet that is being bounced around between the core router and the border router. So the null 0 is for the entire /16, but if there is a more specific route, like a /24, because you've configured an interface, then it will have any packet which has a destination with a longer prefix will use that particular route to get to the destination. Anything which doesn't have an IP address configured on the router will be dumped in the null 0, which is like a trash bin. But any of the buildings that exist, the packets will flow directly to those buildings because they will have a more specific, they'll have a longer subnet mask inside the routing table. Like we've mentioned inside our routing presentations, you could do this either using static routes or you're using a routing protocol like ISIS or OSPF. It doesn't really matter, but you have to remember to have the null 0 route so that you don't have things bouncing around in your network.